Okay, I want to talk a little bit about the next lab. It's ARM with ESP8266AT. So last week's lab, you connected up your ESP8266, you put the AT firmware on it, and then we did a little hijacking of the ESP32 board that you have just to use it as a USB to serial interface. Well, now we're going to disconnect the ESP32 and we're going to connect up our AT firmware to our ARM board. And so we'll hook up to the serial transmit and receive and a ground connection on the ARM board over here. So then instead of us being able to type in AT commands, what we're going to do is we're going to send serial data as if we're typing in to the ARM board, and then we have to wait for appropriate responses. And so it says follow the week 9 ARM with ESP8266 documentation to set up the required hardware and software. Copy your TFT Touch example to TFT Touch AT, and then there is a set of files that I want you to put into your drivers, kind of like we have with our TFT drivers. Put a set of files over into the drivers directory that I have included in a zip file on D2L. And there is some sample code there to get an AT response, and essentially just calling the UART and saying, instead of you typing in AT, sends the how UART transmit, sends out the AT command and waits for responses back. And so where typically you see AT and you wait for an OK, you can actually use these libraries and say, wait for OK, and then don't do anything, just sit there and wait till that sequence comes back. And so there's some samples there. There's the initialization file to set up the AT, and then there's a send, I think there's a send data function, which you can look at. And I want you to make a send, ESP send TCP, and I want you to pass in a server address. That's the server address of packet sender. We're going to send to the same packet sender that you did last week, except you're going to use your ARM board to do it. And then the data. And so the functions you need to add are in something called espdatalogger.c, and I want you to send your name, thermistor temperature to the server at a 5-second rate. So you have already reading temperature on your TFT board. It's already printing out on the TFT screen. I just wanted to be able to connect Wi-Fi to the server, which happens to be our packet sender software, and be able to send the temperatures every 5 seconds. Now that's so you don't have to wait a whole bunch of time. Typically, if I was actually going to make something that was going to send temperature, if it's like room temperatures, maybe I'm building maybe a home monitoring system, you don't need to send it every 5 seconds. Temperature probably every 10 minutes would be more than adequate. But you have to look at your case. It says, to the Lab 9 D2L assignments folder, upload a screenshot of your or photo of the sent packet on the received TCP server. Upload a screenshot of your photo of your name and temperature captured on the logic analyzer we looked at. So you all have those little logic analyzers, and upload your ESP send TCP function. So I just want that function that you wrote to be able to do all of this. And so here you see I have, for instance, TCP, my name, and it says, I don't know, 19.2 degrees, and then it's just showing you that every 5 seconds. Then, oops. And then on our logic analyzer software, which is called PulseView, from a company called, organization called SIGROC. You see my name, for instance, Mel colon space, and then the temperature with our carriage return line feed. Okay, so I want to see a picture of that. I want to see a picture of that, and I want to see just your TSP send function that put all of that together. Okay, so this is very much like you were just sending last week, and this is making sure you can see. Now, one of the things about the logic analyzer that's helpful in this kind of mode, if I'm sending serial data, I may think I'm sending out the data, and I may be cutting off the data, maybe not sending the same amount of characters, or the Wi-Fi coprocessor may be sending me back errors, or maybe not understanding, and I have no idea what's going on unless I have this kind of window into the communications, and we do that with this logic analyzer. Okay, and so it says, follow the Week9 ARM with TCP IP. And so if I go and look here under the Week9 ESP8266AT firmware. Now I'm assuming everybody has it all working. You've done it by talking to it and sending data from last week. It says, make a copy of your TFT Touch project and call it TFT Touch AT. I'm assuming everybody changed the name of the IOC file. You do a make clean and then regenerate. So we have a TFT Touch that should do everything that the TFT Touch AT that should do everything TFT Touch did. And then download and extract the ESP8266.zip file from the Week9 folder and put the extracted folder in your drivers directory of your TFT Touch AT project. And so just kind of like we have our stem win, you put it in there. Now I'm assuming that everybody then knows how to go and include that directory by right-clicking on properties and finding where all the include file, including those in the directory, so it recognizes it. The ESP8266 driver comes from controllers tech on the internet. There's a whole bunch of nice examples of programs of using everything from DMA controllers to A to Ds to all sorts of things. And one of the things that's nice in there, is an interface sample code for interfacing to the ESP8266 AT firmware. And so that's where that ESP8266 zip file comes from. I just extracted the files that you need to send out the data. He's got an example of being using it with a web server. He's got another example of it going to a different cloud-based system, and so we're just going to use it. The files in there is setting up the UART on an interrupt on receive, and he's got a routine that looks through a FIFO buffer to be able to wait for characters. So you could call a function wait for OK, or wait for connected, or wait for IP, or that kind of thing. So you don't have to write it. He's written a nice one. It works well. And so that's why I grabbed those files. So all you have to do is have a look at these examples that they've got and use that. We're going to use UART1. And so that's free on our board. Excuse me. So it says configure UART1 on PB6 and 7 to use an interrupt. So I zoomed in kind of here. So over on PB6 and 7, you select them for the UART1. So one of them's transmit, one of them's receive. You're going to pick the standard 115.2. If you just leave it all alone, it's 115.2, 8 data bits, no parity, 1 stop bit. So that's what we'll use. You don't have to change any of that. The only thing, in order to make it work with the library that we're getting from controllers tech, is just to enable the interrupt, because they're going to use that interrupt for his software. So save this and generate the project. So because we collected it, because we checked interrupt, it's going to generate the interrupt service procedure. So in the interrupt service procedure, there it is, the USART. You'll see a UART is a universal asynchronous receiver transmitter. And so this is a UART, but you'll see often referred to as USART because he integrated into the module the ability to do synchronous stuff. So SPI and I2C and things like that is in the same silicon. Okay, so you can see we're using the UART part of it, but it can also handle different functions using SPI or I2C. So by default, when you go, this is generated. There is a HAL UART IRQ handler, and it's just commented out, and the controller's tech has implemented UART ISR, and so we pass in that. Okay, so as long as we have the drivers, they're pointed in the right place. And it says to initialize the node MCU, use ESP and net my SSID and my password. So we would, for instance, you need to include the right header files that are there, and then include my SSID, for instance, up in the lab, our bakery 204 and the bakery's password. And once that's going to connect the Wi-Fi to there. So you wouldn't necessarily want that in your while one loop. I don't want to keep connecting, like connect once, right? So when you're starting up, otherwise it'll spend a bunch of the time. You connect up to bakery router and then you disconnect from the bakery router. Every time it'll run this, it'll try and connect. It's already connected. It'll disconnect. It'll do a bunch of things. Things will time out. It'll loop around again on your while one. It won't be connected because it'll have failed trying to connect last time because it was already connected and disconnected, and then it'll connect up again. And that's just a whole bunch of overhead you don't need to do. So when you start up outside of the while one loop, connect to your, now you could do it, for instance, if you had the touch screen, you could have a button that says connect, and it just runs that every time you do connect. Those are all options. I didn't say you had to do any of that, and it'll work just fine if you just put it above our while one. Okay. So I want to just, let me just see if I've got here. So you need to include ESP datalogger.h. It calls a circular buffer, and so it's got a head and a tail, and essentially it will, when it gets characters in, it fills up the buffer, and then when you read, it makes it kind of match up. So you can use things like in his data logger software to say a wait for something. So you can get a bunch of stuff in the ring buffer, and then you can go through and parse through it till you see a certain character. So if we, let me just open it. If I, so if I include ESP datalogger.h, so it has a few functions. And again, the sample is, I've got a link over at Controllers Tech if you wanted to see how they implemented in a few things. There is ESP and net, and that's what we're calling from our main program, and we're passing in the name and password. And then it says use UART send string, and so that's part of the HAL interface to go and send it. And we're sending, for instance, in the initialization, AT plus RST/R/N, which should come back with an OK, if that's what we were doing when we were typing it in. And then it says, OK, give it a second, and then it says UART flush, so it keeps clearing whatever was out in our buffer, and then it says, okay, UART send string AT/R/N. So we just did one, then didn't care about things. We send it out again, and then it says wait for OK. So it's going to parse through whatever's coming back from the Node MCU module and looking for an OK, and it's going to sit there until it sees an OK, and then when it sees an OK, it just says, OK, clear out whatever's in the UART, and then wait for the next thing. And then the next thing is AT plus CW mode equals 1, and CW mode being 1 or 3 will work either one. And so UART send string AT. So this is just like you guys were typing last week, except the computer's doing this at 1:15.2. And again, the reason we're using this is because we could have just done our how UART transmit, for instance, but seeing that a buffer is implemented, we can just wait for the OK to come back from the command. And then again, sprintf, we used sprintf, or some of us did last time, AT plus CW join access point, %s, and slash quote, because I want the actual quotes to show up. So this is our escape sequence to be able to let you actually print a quote, and slash quote, %s slash quote. So those quotes are going to actually show up, and whatever's in %s, and that's our bakery 204, and then %s again for our password. And so we send that data out, and it says wait for got IP. So when it goes through and finally connects and gets an IP, you're able to see that that all happened. And then again, we do a flush. AT plus SIP-mux equals 0. It wants that to be able to send a TCP command in the initialization. That's what it says anyway. I don't think we had to do that. And then it has a ESP send data. Okay, so this is the initialization done. It waits for it all to be okay. And so if I called, for instance, ESP init, that hopefully sets up and says I'm all connected to Wi-Fi and I'm good. And then there's an ESP send data. This was an example to go send something to a cloud-based service that needed a API key, a field number, and that kind of thing. And so I can keep most of the kind of thing here, although I want you to have an ESP, a copy of this called ESP send TCP. And instead of, for instance, you sending to whatever address this is someplace out on the internet, I want you to send to your server, and we're passing in, I gave you a prototype to pass in the server's address, okay, which is wherever your or some other person's packet sender is. This says port 80. You were on port maybe 7777. Some of you did 6666 or 1234 or something above 1024. And then again, SIP start, we wait for an OK, for instance, and then it has a whole bunch of stuff that's not related to your stuff. You need to put in how many bytes that you are going to send, and then send all of that kind of thing as well. So this is a good kind of sample to wait for. One of the interesting ones, when you do SIP send, it doesn't give you an OK, it gives you a prompt to say, wait for the number of characters that you typed in. If you go back and look at last week's, so how you sent in, you need it to work the same way, okay? And so I want a TCP send character. That was kind of weird. So I want you to have a TCP send and send your temperature out. And of course, your temperature, you're going to use a sprintf, convert it into a string, has your name, colon, space, and send that out. Okay, so I want that function. So based on this, chances are you'll send things and you may find that you're not, or it's hanging up, or it's waiting for something. If you have your logic analyzer set up on your transmit and receive pins, you can actually monitor your data going out and coming back, and seeing if you're getting an OK, seeing if you're getting things where you're expecting them. Okay, it's a trickier problem to do if you are trying to do this this serial communications back and forth, and you don't know if the coprocessor is responding correctly, or where it's easy to have one extra carriage return or a wrong count in the number of characters that you're sending out, and then it doesn't respond. I've had it before when I've been looking at things and it just always returned back an error. And unless I had it on the logic analyzer, I wouldn't know that it's sending me back errors. And so I've messed something up before. Maybe I didn't put it in the right mode or that kind of thing. Okay, so that's the software there. There's a link over to it. It's essentially doing everything we did last week, except I want the ARM to be talking to this as a Wi-Fi coprocessor, and I want it to be sending your temperature out, like I say, every 5 seconds to the server, okay, with your name attached to it. Any questions on that? Or so that's the upcoming lab, and again, we also have a test this week as well. The test should take you around an hour, and the rest of the time you have this, and you have some of next week as well. We're going to do a little bit more next week, but you'll have some of the time as well next week to finish this off. There's just a little bit more on having a look at where some of the data is on the wire. Right now, we're looking at the serial data. We also want to look at the data that goes onto the wire. So we'll use the code that you hopefully get started on this week, maybe finish up next week, and have a look at some of the stuff that's being sent out on it. Okay. Yep.
Which lab is the test up to?
Oh, the test is up to the TFT, so nothing past that. TFT touch. It's again, it's open book, it's open lab. The type of things I ask are, for instance, if you are setting up, DMA, I could say, okay, in the lab, what DMA channel were you on? Like, do you know where to go find that? What stream was it? Again, on DMA, do you know where to go find that? If I ask you where a vector table is, can you tell me the file your vector table is in? What is a vector table? Again, it's open book. As discussed in class, don't go just Google what a vector table is and tell me it's something used in mining or something. I don't know, but let me just